Two parallel conductors carry current in opposite directions as shown in the figure. One conductor carries a current of 10 amperes. Point C is at a distance d by 2 to the right of the 10 ampere current. If d is equal to 18 centimeters and I is adjusted so that the magnetic field at C is 0, then the value of the current I is to be calculated. So the magnitude of a magnetic field due to a current carrying wire is given by the Biot-Savart's law, which tells us that a magnetic field due to a long wire would be equal to mu naught by 2 pi into the current divided by the distance of the point from the wire. The direction of the magnetic field would be given by the right hand thumb rule, which states that if we make our right hand into a thumbs up gesture and point the thumb along the direction of the current, then the curl of the right hand fingers would give the direction of the magnetic field. So in this case, due to the wire on the right hand side, the magnetic field to its right would be into the plane, and the magnetic field on the left hand side of it would be out of the plane. And for the wire on the left side, which is carrying a current I, the magnetic field would be out of the plane on this side and into the plane on this side. So we see that both the wires apply opposite amounts of magnetic field, or rather opposite signs or directions of the magnetic field at the point C, and it has been adjusted so that it is equal to 0. So you have 0 is equal to mu naught into I by 2 pi into what is the distance between the wire that is carrying a current I and the point C. That would be 3d by 2, and we subtract from it mu naught into 10 divided by 2 pi into d by 2. So this becomes mu naught I by 3 pi d is equal to mu naught into 10 divided by pi d. Mu naught, pi and d cancel out. We have I by 3 is equal to 10, or I is equal to 3 into 10, which would be equal to 30 amperes. Hence option B is the answer.